Hey there, Ravens. We're back and we're doing the Avogadro's Law homework problems. And let me pull up the pen. Okay, so here we go. This time we have grams of oxygen. So we know that we have 46.2 grams of oxygen gas, which is O2 is its formula. And I can tell you right off the bat, if we're doing gas law problems, we need to change that into moles. All right, so we know that 32 grams of oxygen gas, remember 16 from the periodic table times 2, is equal to 1 mole of oxygen gas. Okay, so 46.2 divided by 32 is going to give us 1.44 moles of O2, and that will equal N1 for our writing down what we know. We also have a volume of 100 liters, so we know that V1 is equal to 100 liters at a particular temperature and pressure. What volume will 5 grams of oxygen gas occupy under the same conditions? So V2 is going to be our unknown. That's the thing we're looking for. And we're going to have to, again, convert 5 grams of oxygen gas. Okay, so 5 grams of O2 times our same conversion factor, 32 grams of oxygen on the bottom, 1 mole on the top, and that gives us a value of 0.156 moles. And that is going to equal N2. Okay, so and we understand we're looking for volume 2. How we're going to get there? We know from Avogadro's law, V1 over N1 is equal to V2 over N2. And this time we're solving for V2. So V2 is going to equal, I don't know why I drew that line right there. V2 is going to equal N2 times V1 divided by N1. And if I plug in my variables, so N2's over here, that's 0.156 moles. Volume 1 is the only volume we know, which is the 100 liters, divided by our N1 value, which is 1.44 moles. And when we do the math on that, we end up with 10.8 liters. And let's see, we reduced our number of moles, so N1 to N2, N1 to N2 was a big decrease, and we also saw a big decrease in volume. So our answer makes sense. This would be our correct answer. Okay, and that is it. Next is ideal gas law, and we'll get that on the next episode. See you soon.